tries to help exploring large data sets with hierarchical graphs. Now, the project is on smalltalk on this URL, and later I'm going to do a little hands-on demo session, and if you want to follow it, you can load Quicksilver into your Pharo image and go along with me. So the structure of the talk will be, first I will tell you a little bit about the general concept of hierarchical graphs and how they help in dealing with large data sets. Then I'm going to talk a little bit about the history of Quicksilver and the relation to software node. And then we'll look at some case studies, and then I'll do this hands-on demo. And at the end I'm going to talk a little bit about the architecture overview and how Quicksilver could be integrated in this MOOS platform. So, this is a large data set. It's unordered, it's chaos. What do you do with it? How do you interpret it? Well, you find patterns. You do this automatically, or you can do it manually. One way to do it is to look for similarities between the elements. And so you can group elements based on similarities. And if you do this recursively, what you get is a hierarchy. And so hierarchies in general are a very good way to deal with complexity, and we do this all the time actually. We use hierarchies everywhere in politics, in business, in economy, and it's a very good tool to deal with that complexity. It's a divide and conquer technique, because instead of looking at all the elements at the same time, you look at representations of certain elements. So you go one level up in the hierarchy, and this element will then stand for other elements. So this makes hierarchies very usable. And now the next step in dealing with large data sets is to find relationships between the elements. And so, for example, if this hierarchy would represent a software system, you could say that, let's say these are methods, and these are classes, packages, systems, ecosystems of software. So, if you have like this method, we would call this method, that would be a relationship, that would be an invocation. So now, to use this information again effectively in a hierarchy, it's important to propagate these relationships up in the high graph. So what you do is you say, oh, because these two methods have a relationship, their parent classes also have a relationship. So you don't have to look at all the methods again, you can just look at the class level and see, oh, this is the relationship between them. Now, if in a data set you have lots of relationships, of course, and if you do this propagation of relationships with all the relationships, you get the hierarchical graph. So you have the hierarchy, you have the relationships, and these relationships are propagated up in the high graph. Now, a tool that exists that uses this technique already is Software Node. This is a screenshot of Software Node. Software Node is developed by Mircea Lungu. And so, if you want to get some more information, there's a link to it. What we see here on this image, it's Software Node visualizing itself using polymetric views. It also uses tree maps, so that you can. So these are packages, the big nodes, and the edges are relationships between those packages. And it uses tree maps to let you see on the class level in the hierarchical graph. So, and it can also highlight certain properties. For example, here it highlights frequently changed classes. So what you see that with this orange here, these are the classes that can change a lot. What Software Node also can do is filtering, so you can filter some nodes, and you can also share generated views. So you can save this view and save it to a global thesis, I was interested especially in this concept of collaboration, because I think if you want to do software analysis, it's important that you can. First of all, it's an ongoing process. You should do it all the time, and it should be accessible. It should be easy to do, and you should be able to share and collaborate on these analyses. So we thought about this vision, and we thought the first step might be to get to this point would be to port software node to Pharo, because it was implemented on VisualWorks, which is a commercial small talk environment, which we don't like very much because it's commercial. But so the first step was to go to Pharo, make it open source, and get some key aspects of software node there, and then try to reach this vision of a collaborative environment for software analysis. Now, so I start porting it, and if you are occupied with one topic for a long time, you start to see that thing everywhere. So for me, I started to see hierarchical graphs everywhere. I saw them in politics and economy, and just everywhere was hierarchical graphs. So we thought about this, and we thought, why not generalize this concept and use it for anything, not just for software, but for any kind of data. And this is this is the idea of Quicksilver. This is also the reason why we renamed it. Well, because we thought it would be something which is not only software, so that's why we searched for a new name. And since I used the variable HG a lot for a high graph, we chose Quicksilver because it's the chemical symbol for Quicksilver. So that's why it's called Quicksilver. Yeah. So to verify this thesis that you could use hierarchical graphs for large data sets and for any kind of data sets, we looked for data sets where we could test this thesis. And one thing we found was Stack Overflow. Now, who uses Stack Overflow regularly? Who knows what okay. Who knows what Stack Overflow is? Oh, the second. Super second. Okay, so we got a database down from Stack Overflow, and what we got was a dataset with data from 4 years, from 2008 to 2012. It has 1.3 million users, 3.4 million questions, 6.8 million answers, and a lot of other stuff. Interesting side note, these are the top 10 tags. Smalltalk was not even the top 100. We have to change that.
That's what I didn't say.
Sorry?
Nothing.
So...
Stack Overflow is like problems.
So we looked at, we searched for metaphors. How could we look at this data set? How could we use a hierarchical graph to interpret this data? And what we found is that you could look at Stack Overflow like it was an economy, because actually it is. What you trade is knowledge, and what you get are points. It's a concept of Stack Overflow. So if you have this reputation as those who use it, and if you provide good knowledge, if you provide good answers or good questions, you get a lot of points. And so this is the commodity we trade here. And you also get power. With more reputation, you get more power on this side. So it's also a bit a power game there. So the total wealth of Stack Overflow in this dataset was 178 million reputation points. And 57% of these reputation points were spread to users who had provided the location in their profile. So these were used to geolocate. Why do I say this? Because when we think about economy, one thing we wanted to look at was the geopolitical economy of Stack Overflow. So what we did is we enriched the data set with geolocation information for all the users, and this is how we built the hierarchy. So let's take a look at this economy. No, sorry. First, I'll explain the economy a little bit in detail. So at the basis of the economy, we have certain amount of points. If you gave the answer to the one who asked the question thinks, oh yes, this is the right answer, you get more points. If you post some spam or something else, you get points deduced. So this is how this economy works. So with this metaphor in mind, we built this hierarchical graph, this economy, and this is what it looks like. The flags were added later, but what you can see, well, the first thing you see is actually it's pretty nice that it's a global economy. So you really see there's people from everywhere participating in that economy. Even some guys from Antarctica or I don't know, but they're helping as well. So, and what we see here, of course, two big players in this economy is North America and Europe, almost the same size. So these numbers and the size of the nodes represent the score inhabitants of these areas got for their answers. So if you give good answers and much answers, you get more points and more size.
You know what is really sad is this is the state of Africa.
Yeah, and it's the only really country is South Africa, and not much else. Yeah, that's true. And so, and the edges are just amount of answers given from someone in this continent to someone on the other continent. Now, interesting also is that Asia is importing a lot of knowledge, not exporting as much. And
we shouldn't answer those Asian guys anymore.
But language plays a role, of course, I think a very important role. You can also see that in, well, it's an English-speaking side, and of course it originated in America. So, and you see here in Asia, it's actually the countries which have a certain affinity to the language, which are bigger, and I'm sure if it would be an international side with many languages, or then it would look totally different. So this is what you have to think about that. That's a language thing as well. So let's look at how we built this hierarchical graph. Now this is the API of Quicksilver at the moment. So what we did is from this database model, we built a simple model of Stack Overflow, and we started creating a hierarchical graph. And we say, okay, new object hierarchical graph with its base nodes, which are users. So the users are our leaf nodes. They are at the bottom. And we give it a name. And then we say, okay, so we build this hierarchical graph bottom up. You could also give it a root node and build it upside down, top down. But in this case, we build it bottom up. So you have to tell the hierarchical graph how to build this hierarchy. And you say, okay, for every user, call the method country, it will give you its parent. For every political area, also call the method parent, which will give its parent. So now you have the hierarchy, and now what you want to do is to add the edges. Now the edges are answers, so we give all the answers.
So wait.
Yep.
How do you stop?
If it's nil, you stop.
Okay.
Yeah. So if the political area has no parent, then that's worse. That's the parent. And so yeah, for the edges you give the answers, and you just tell it how to get from one user to the next user. So the user who asked the question to the user who answered that question. Now I will tell you about how to visualize that hierarchical graph a little bit later. But first, let's take a look at another example.
Wait.
Yep.
So, what was the format of the database, and what are the tools that you used to import it?
Okay, the database is PostgreSQL.
Okay.
And I used just Pharo and Glorp DBX
Okay.
to get just to make queries, SQL queries. And I used SQL queries to make. I really had a simple model. I made some classes as a Overflow user, and I made a geopolitical little model.
What I wanted to know, this is also okay. So you didn't use any meta-programming trick to generate the class of the flag?
No, this is done manually. Yeah.
Makes no little sense to do something like that.
So let's look at another example first. Sync. Sync is, as you probably know, the HTTP documents framework in Pharo, and I did a little hierarchy for this as well. This is the way to do it. This time we used the Moose model, so we didn't have to actually do much. We just generated the Moose model, which is really easy. And then we started it's the same thing. We started all methods as leaf nodes. So we have methods at the bottom. We build the hierarchy. We say family's method belongs to it's the parent, family's class, parent package is the parent. Now this one is probably pretty ugly. The how would I get from package to namespace? Not as ugly as this.
No, you can't.
You can't?
No, because it's an end-to-end relationship.
Okay. Anyway, so this is a little hack because I wanted to have one root node. So I used this thing to get the small talk namespace as one root node. Anyway, then as edges you use all sure invocations, pretty straightforward. So let's look at how we visualize this. I will show you, of course, the visualization after this.
No, you need to get stuff first.
Yeah?
Yeah.
Oh no, you have to imagine it and I'll show you. So there's a visualizer which you just give it the hierarchy graph, and then you, for the hierarchy graph, as you saw, you use tree maps, and so you can use tree map, it has to know some weight, and in this case you use number of lines of code. And so this method weight synthesizer actually does this. It calls this method number of lines of code on all the leaf nodes, and then it aggregates these values in the hierarchy. So the class will know how much lines of code all its methods have. I know you could do this differently in a Moose model, but it's just to illustrate that this is possible. And then some configuration stuff, the visualization, I'm not going to detail it there, maybe show you later. But now we want to highlight some things. And it's just an example. It's a linear colorizer. So I say for every method, take the number of comments and make that blue. So if it's white, no comments. If it's blue, much comments. And I did the same for number of invoked methods, but this time in red. So white, no invoked methods, and much red, a lot of invoked methods. So now let's look at how this looks. This is the picture.
Wait, can you go back?
Sorry?
Can you go back?
Yeah.
So, what is the... Because when I read that, I have problem to understand what you will color.
Okay, so we have the base entities are methods, right? And
Okay,
I
so you say that you can have two colors that compete
yes,
with each other. Okay.
Yeah. And
okay.
So that's, you see for example this package is pretty big, this is sync tests. Maybe you can read it a bit smaller.
No, that's good.
But these are tests, you see it's more red than blue. So, which is logical because tests are probably invoking a lot of methods, and maybe not as many comments as all the classes. You see this is the sync HTTP client server, it's more blue than red, meaning cool, it has comments. And here in the sync HTTP core, some white stuff, but also blue stuff, so comments there. And again, the size is just lines of code. The edges are limitations, so of course no surprise there as well. Tests are calling a lot of methods in the core packages. The layout and the visualization is a work in progress. This will get prettier, but this is the status as it is now. So let's do a little hands-on demo. Is there anybody who wants to follow me? Yeah? Okay. Good. So I thought about what can I show, and I talked with Mircea, and Mircea often has the problem that he has not enough space on his laptop. and he uses this tool called disk inventory, which
Yeah.
shows you a tree map and it shows you where are the large files, and it's implemented in C, so we said let's do that in Pharo. So let's do that. Because I also have this problem often that I don't know where are the large files and what can I do. So let's try to find out.
And soon it will be vector graphics. So that's cool, huh?
Absolutely.
Okay, now
And just mirror it.
yeah, probably yeah, it should be able.
Yeah, do we do the
Command F1. Or it's not that.
Yeah.
Okay, so are you ready?
I already programmed.
Okay, what we'll need is a hard graph and a visual.
Wait, anybody else following?
Oh, sorry.
Do you have the code?
No,
Quicksilver.
We have to load the code?
You need
Yes,
to
so
download.
it's Gopher.
Oh wait.
Can I share the?
Can you share?
This is the something small on top.
No chance.
It would be nice to read under loose.
Yeah, it will be there once he creates a configuration.
It's done.
Ah,
But you need a moose space or a Pharo?
You need moves.
Yeah, but not for the demo.
You need glamour, so
You need it. So just take a moose image and load this. I just added it to the moose conf tweet.
Before that?
It's just loading the package, not the configuration. At the moment.
Yeah, because the configuration is not good.
The last version?
Yeah.
44?
Yeah.
Okay. Done.
So.
Downloading a random thing and executing it as a batch script. I really hate that. It's asking a lot of faith of people.
that's true.
That's just nuts.
but
The way to get Pharo.
why?
You're asking people to trust a lot to execute random stuff as a bash script.
And then, what's the solution?
Is it?
Well, who trusts? No.
It's just crazy.
It is, because if that's how it
Not
gets
many people in the room, I know, but
yeah, no, but
I don't think it happens.
even this, if you get
If the server gets hacked, then everybody gets hacked.
Yeah.
Everyone.
that's true. Yeah, the server gets hacked, then everybody gets trust is good.
Yeah.
Okay, are you ready or?
Doesn't work for me.
No?
Oh, you need the Smalltalk Hub magic.
Oh,
There is the
Oh yeah.
famous script that was circulating
on Twitter.
on Twitter. And I sent the mail to the mailing list with the link to the code.
So,
this time, like I said, we will build the hierarchical graph top down, because a file system is normally in the directory and then you go down to the files. So this time we're going to do it top down, and now I just have to tell a directory how to get. Oh, sorry, I forgot to add the root node first. So node. Now we're going to start with the directory. Now I have this directory which I suspect to take a large amount of space. I'm going to see if I can delete anything there, which is users. Don't write the same thing because we probably won't have this as file reference. Okay, this is our root node. Just tell me if I'm too fast or if you have questions. Now, how do we get children? Well, if it's a directory, it has children, and if it's not, it's a file. So E is directory. True. Just give us. Is it big enough? Yeah. So give us just the children if you're a directory, and that's everything. Now we have our hierarchical graph. No, that's handled automatically. So because if it doesn't return anything, it's considered irrelevant.
And if it's false, the expression will be new. Yeah.
Sorry.
In your expression, if it's not directory,
Yeah.
then if true will answer new.
No.
No, it will be false.
If it-
To say if false, no.
Yeah, but it'd be false, but false. I think it's interpreted as if it's false or nil, it's just it doesn't go any further down. Okay, so that's our graph. We don't have edges. Well, maybe could add symlinks or anything, but we leave that on. We just have the hierarchy. So let's visualize that. With the hierarchy bit, and we need to give the visualizers this weight so it can show us the hierarchical graph as a tree map. So we say weight. No?
Not the same. No same.
Oh yeah, sorry. Weight synthesized, and we take the method size, which will give us the file size, and it will aggregate this information, this attribute into the tree. And now let's say, or let's look at it first. This show and do that. Okay, so now this is my folder. It has a big file here, which is SO data image, which is my Stack Overflow image, which is 700 megabytes. Can't delete this right now because I use it. But I don't like to search around for other files. Let's highlight something. Let's say if I want to delete something, it might be files that I didn't touch for a long time. Maybe I don't need them, so I just delete them. So let's tell the visualizer to polarize all the files which are old. So let's do that on all the nodes, and then say valid. So let's take. So this will be a file or a directory, and let's see how old they are. So let's say times now minutes time minus e and 3.
Maybe you should extract it from the graph.
Sorry?
Maybe you should extract timestamp now as in its time from the graph. So fast that we can do it.
It's,
No problem.
and then look at this. I think instead of sections, I'll use days because it's a bit easier to handle. So, so then, which color are we gonna use? Let's use blue. So let's look at that. Now, the bluer it is, the older it is, or the longer I haven't modified it. And what we see, like I said, I can't delete this big file because I'm needing it and I'm probably needing it again. But here we have something which I don't use, which is variant J. Well, I didn't use it for a long time, but maybe I'll use it again. What do we have here? This is an MSE image of use. This is an Oracle MSE image. I think I'll be able to delete those two because Andrea has now all the MSE files in his thumb drawer. Also there, which we will talk about later. So yeah, that is how to do a little file view. Is that okay? Could you follow with that? Do you have any questions related to this demo? No.
No questions.
I'm still not quite good with the visual top-down selection because you kind of form in query.
Yeah.
So in top-down you actually answering the collection of children.
Mm-hmm.
But if it's directory, then what is the answer of this expression? If it's directory.
False.
If false, self-halt.
You wanna look?
Oh,
So
can you
basically,
just add if false
I can.
and return 0?
Well, no, not 0 because that would be then because it's an element. I have to run there because to let
But we want to return email.
no or false.
So what
I wanted to make
what you should return? False, new, or what?
both.
Something
It's
else?
flexible because I don't want to write if false all the time. So
Yeah,
either it's false or it's
In fact, doesn't even work if you just say e children without doing the if.
maybe. I don't know.
think
Maybe I don't
If
know.
I remember correctly, it's quite robust. So it does. Even if it throws an exception, it just ignores that.
No.
I'm not sure about that.
No.
No.
You can see.
And
Oh, no, now it says another problem.
this is
No,
the
it's-
file.
So it's
Yeah,
not.
so it's a file and it doesn't work. Children is not the
Okay,
file
good.
on the files. So.
No, it does return. If true, if false, returns nil.
Yeah, but that's implicit. You
No.
will see it when you.
Yeah, but if true, if false, returns nil. In Pharo.
I know. But you see that you have implicit rule, rely on some implicit rule, and this is not very nice, I would say.
Okay. Well,
I'm not sure.
okay, let's go to the last slide. So this is a quick overview of the architecture. As you saw at the base, certainly is this hierarchical graph data structure. This is the core. Visualization is done with the help and collaboration of Rossal. For example, there is no tree map layout in Rossal, so we made that and we contributed it to Rossal. So if you do anything with Rossal, you can use tree maps now as well. The interaction is based on Rossal, the one we saw the highlighting and the other stuff, which I didn't show so far. But this is a work in progress. This is also a work in progress. And to reach this initial vision, which I talked about, it'd be cool, of course, to have some kind of UI. And at the end, it would be cool to have some kind of collaboration. And ideally, I would like to have that on the web somehow. So I think it would be really cool to have all this stuff on the web somehow at the end.
So what is the data structure? So you have a mapping. Wait, is it a normal? You have a
this case was a user of that.
Okay.
Or it wraps a moose, or it wraps kind of a moose model, a reference to a moose model.
So this means that when you want to access, the properties of an entity, you always write node entity matrix X.
Which case, when you build the high graph,
Just data structure. You have the graphs with the nodes, and inside the nodes you wrap your entity. So